We're going to talk about predicates. This is in Module 2. This is the third video, and it is from the textbook, section 3.1. Okay, so in the last video, we saw an argument like this. If Socrates is a man, then Socrates is mortal. Socrates is a man, therefore Socrates is mortal. And we learned how to take the argument form for that and determine if it's a valid argument. But it's very specific. This refers only to a single individual. Over here, we say all men are mortal. Socrates is a man, therefore Socrates is mortal. This refers to a group. So what is the argument form? Well, maybe we say this first line is P, and the second line is Q, and this is R, so we have P and Q, therefore R. Well, that doesn't make any sense. And in fact, that's not going to work. What we have now is we have the need to use the fact that this is a group and then associate Socrates with that group. Right? So we can't do this with the simple logic we've learned so far. We need something called predicate calculus or predicate logic. Okay, so that's what we're going to talk about. We're going to talk about the predicate part in this video. Okay, so what is a predicate? It's a sentence. Now notice this does not say statement. It is not a statement. Right? It is a sentence with variables like X or her that becomes a statement once specific values are substituted for the variables. So we saw some of these before. When we said before X is greater than 5, I said that's not a statement because we don't know the truth value, but this is a predicate. Or she is a math major. Again, it's not a statement because we don't know who she is. It's a predicate because once we know who she is, once we know the variable, we can substitute it into the sentence, and then the sentence becomes a statement. Okay, so predicates are a lot like statements, except they have these variables in them. And it's very important that we talk about the domain and that we know what the domain for a certain predicate variable is. The domain is the set of all values that can be substituted into the variable. So just like in algebra, we can specify the domain of this predicate, and we're going to see what that means in a moment. So here's an example. Here we have a statement, right? This is a true statement. We can evaluate it. A predicate, this is just the name of the predicate. The predicate itself is right here. And we don't know its truth value until we substitute a value for X. Here, so this is the actual predicate. This is the name of the predicate. And this over here is the domain of the predicate. So, the question is this predicate true? Well, it depends on the values of x. And the domain, here we say x is in the real numbers. That's what this fancy R means. So we have, this is the real numbers. We have the integers. Rational numbers, for some reason, is a Q. And so on. I'll define them as we come across them, but this is the real numbers. So let's pick some real numbers. Well, let's do this in blue. What is P of 3? Is it true or false? Well, let's work it out. P of 3 is going to be 1/2 3 cubed is greater than 3, which is going to be 1/2 3 cubed is 27. It's greater than 3. Well, this works out to is 13.5 greater than 3. Yes, it is. So this is true. This predicate value, P of 3, is true. Let's do another one. Remember, we can substitute any real number in. I'm choosing integers just because they're easier to do the math, but we could put any real number in. I'm going to do 2. So we have 1/2 2 cubed is greater than 3. This is 1/2 times 8 is greater than 3, which is 4 is greater than 3. Is that true? Yes. This is another true predicate. And then let's do one more. P of 1. 1/2 1 cubed is greater than 1. Well, this is 1/2, 1 cubed is just 1. So this is 1/2 greater than 1. Nope, this is a false predicate. Okay, so we can label P1, P2, and P3 as either false or true. This was false, this is true, and this is true. Okay, so this is how we can determine the truth value of a predicate, and this is also how statements and predicates differ. Right? This is a statement, but that's only after we've substituted the value 3 in to the predicate. The predicate itself does not have a truth value until we've substituted something in. So that is a predicate. One more thing about predicates. If we have a predicate, P of x, and our variable x has domain D, then we say that the truth set of P of x is the set of all elements of the domain that make the predicate true when they're substituted for x. So for example, we have this, let Q of n be the predicate, n is a factor of 8. So what's the truth set? Well, it's going to depend on the domain. So if we say, let the domain be the set of all integers, right, then what integers are factors of 8? Make this predicate true, right, that we substitute in. So we can say, well, if n is 1, 1 is a factor of 8. Right, what else? What other things are factors of 8? 2 is a factor of 8. We can take 8. We can do our little tree here. 2 and 4. This is 2 and 2. And 1 is always a factor. So pretty much we have factors are 2 and 4 and 1 and 8. But we also can do negative values. So -2 and -4 give 8. And -1 and -8 give 8. So the truth set for Q of n when our domain is the integers is this set 1, 2, 4, 8, negative 2, negative 4, negative 1, negative 8. If we change the domain, that's going to be different. So for example, if we make the domain just the positive integers, so that's what that little plus sign means, is we're just looking at the positive integers. Then we can ignore those negative values, and it's just going to be 1, 2, 4, and 8 are going to be the factors of 8, and thus be the truth set for Q of n.